talk about your next connected embedded design. There is a high probability that you will need a variety of wireless connectivity protocols, including Bluetooth, Thread, and Zigbee, to make sure that your design plays nicely with other connected embedded devices. But it's not just playing nicely with other devices that's important here, right? We also have to keep in mind our overall BOM cost, size, and power consumption. What we need is a buffet of wireless protocols, a little bit of this and a little bit of that. Hi, I'm Amelia Dalton, host of Chalk Talk. As our devices get smarter, our communication needs get more complex. In today's Chalk Talk, Mark Herveau from ST Microelectronics joins me to discuss the various topologies present in today's wireless connectivity and how the innovative architecture and flexible use of resources of the ST Microelectronics STM32WB microcontroller can help you with your wireless connectivity concerns of your next embedded design. And before we get started, don't forget to click that link. There you can find even more information about this topic from ST Microelectronics. Hi, Mark. Thank you so much for joining me.
Thanks, Amelia, for inviting me today for this session.
So we're going to be talking about wireless connectivity in embedded applications today. And I'm definitely seeing a trend where multiple protocols are needed for end products, especially around that 2.4 gigahertz band. So specifically about this need, which can be challenging to implement and not always cost optimal, right? Mark, can you talk a little bit about this trend in particular?
So definitely, wireless is very important those days, right? You get that on every device all around you in the home, for instance. And all those products are made easier and smarter to work with because of this wireless connectivity. But what you see is also a very diverse ecosystem around them. And I hope we're going to touch base on that today. So it is very important, actually, to identify which application we talk about here, on where we see those needs of multi-protocol. Based on customer feedbacks, we do see a trend in verticals such as smart home, for instance, including intelligent lighting. But we see also that in many other industries.
Okay. So since we're talking about addressing our multi-wireless connectivity needs in embedded applications today, Mark, before we jump into the details, what kind of applications are we really looking at here?
So let's look at embedded application using 2.4 gigahertz as an example, and maybe focused on the smart home. That is, I think, a good example. So here you see, for instance, the home that is filled with consumer products, small appliances, that probably may mainly communicate with Bluetooth, let's say 5.2 in those days, or even some proprietary protocols. We see also other devices like sensors for alarm system or HVAC system, or even metering for gas, water, and electricity that are using specific protocols, usually more optimized for their use case. So here we're talking maybe Thread, Zigbee, Bluetooth Mesh, those kind of protocol. So what we see is that each of those devices present different features based on their power consumption, maybe the reach or the distance, and also even the topology on how the network is organized. So that's obviously a challenge, and the challenge is to build more complex application, coherent application that will centralize and use all those devices and make, I would say, smart home, right? It's not just one silo of one device, but all those devices playing together. So that's really the challenge, is to talk to all those devices at once and in a very central way. And obviously, what is important is to make them interoperable and in a very economical way, because we are talking about embedded systems, right? Price sensitive and possibly sometime also integration sensitive. So obviously, the space is important.
Okay, that makes sense, Mark. Now, can we talk a little bit about the types of topology examples you see for these different kinds of applications?
So it all starts with the screen and the display. Basically, this is where happens the user experience and where the end user is interacting with the rest, right? It could be a smartphone, it could be a computer, a tablet, a TV set. So what we see is basically two different type of topologies that are present. So one is point-to-point, where basically you are going to see devices connecting directly to the interface or to the screen or to the device that is showing up the data. And most likely it's going to be a Bluetooth low energy that is going to be used, but obviously not limited to. And a second one in the second range, and here I'm more referencing other applications, that will use what we call a mesh network. So, and it allows to extend the reach. So here you can imagine many devices across a very wide area. If we are taking again the smart home as an example, we have a very large house, and that would be an example. So you could have, for instance, a backyard lighting system or even some window sensors, and each of them will serve as a relay for the next one, since they're going to extend the range, and some light or sensor won't be at the reach of the gateway itself. So really those intermediate points will serve as a relay. And what obviously, when we talk about those devices, what is important to consider as well in the complete equation of discussion is that most of those systems are small and most often battery operated, not always, but most often battery operated. That induce another problem, that is low power consumption, to extend the battery life of the device.
Okay, so Mark, we have multiple protocols, multiple topologies, and the need for being compact and low power. This sounds awfully complex and can lead to some expensive solutions, right? What would ST Microelectronics recommend for these kind of solutions?
Yeah, no, very true. So actually what we have done in the last 2 years is really to launch in our portfolio a new wireless microcontroller series. It is called STM32WB. And that's exactly address your question. I mean, this is exactly that. So it supports multiple protocols. So we support Bluetooth 5.2, Thread, Zigbee 3.0, Open 2.4 gigahertz, and multiple topologies, point-to-point and mesh, exactly what we talked about before. It is secure, highly integrated, and very low power, so perfect for those remote devices in a home, for instance. And it is a system on chip, or what we call a SoC. So it is on the same device, on the same die or same silicon, you are going to have the application controller, the software stack, the radio, all running under the same hood. And what is good with us is that we provide those software stacks free of charge. So many of them are provided already out of the box. So the good thing also as an added feature, and I was talking about the interoperability between those protocols, is that the STM32WB support the concurrency between these protocols. So you can imagine a very simple device talking on one side Bluetooth and on the other side Zigbee, and making those interfaces between those different worlds or the different silos that do not talk together today. So it becomes very optimal to build those devices based on STM32WB.
Okay, so Mark, can we talk more about the hardware benefits of this new series?
Yeah, so there's many benefits from multiple angles. I'm going to pick just a few of them here. So the first one is a dual core architecture. So interesting, why? Because you don't need an external controller. The controller is inside already. So you get a better integration, cost, and security, and also low power because of that, right? So obviously lower power, you extend the battery life of your product. So many advantages. The other category of advantages is more about at the integration level. So we have a lot of BOM integration features, RF balloon, master clock, crystal USB, LCD booster, to name just a few. And another one that is probably very important for the cost of the PCB itself is that we can work with two-layer PCB. That is pretty optimal in terms of cost for that. And we have a very large series already, just after 2 years of silicon with various packages, memory size, and so forth. Some are a bit more open in terms of protocol, some others are a bit more dedicated. So it's all, really, you have a big choice there.
All right, so Mark, can you tell us a little bit more about this new wireless module?
Yeah, effectively, there's been a new module that got introduced recently. It's a great addition to the WB family because customer that wants to go fast up to market, they do not want to redo the certification, and they don't really want to build a very highly skilled RF team, right? So that module is very, very useful for this category of customers. And the module is very small. It's a 7 millimeter by 11 millimeters, so extremely small. It integrates antenna. It has a lot of peripherals that come from the chip that is inside the module. So that is STM32WB55. This is really simplifying the development for the customer, and so you don't have to integrate those external components because they're already in there, and it's pre-certified for most of the regions, so ready to use and in full production now. So take advantage. It's pretty good stuff.
So, Mark, how would I go about developing with the STM32WB?
That's a great question. So we have development tools that we have developed for STM32WB, hardware and software tools, so two fronts. So if we look on the left side on the hardware boards, here we have 3 boards shown. They are all great support for doing prototyping, but also as pure reference design, so where customer want to copy paste really the schematic and want to build their own solution with their own specificities and differentiation. So on those boards, you have 2 categories. I would say the one in white that are the Nucleo. Those one are chipped down with extension of Arduino, so you can extend with Arduino with features, but all the pins of the WB are exposed to the outside world, right? And the one in blue, that one is also very interesting because this is using the STM32WB module that I was just talking about. It has also a lot of sensors and IP peripherals that are even a small screen. So a great tool to do, let's say, demonstrator to your management, to do the first prototyping and show something very viable. The second front is really on the software tools. So we have a great software tool platform that is called STM32Cube. So it's really streamlining the software development experience for any developers. So that's a great tool set. It's very popular, and actually, we're actually very proud of it. It is, let's say, a simple graphic user interface. So you can configure the pins, generate the code, program, edit the code, and do many other aspects of that for the pure development. You can also do the power usage estimation that I was talking about. Low power, super important. So you want to use this kind of tool to do the optimization, and also the RF monitoring. So if you end up choosing the chip down solution, then having a tool to monitor and to help you for the certification step is very important. So all of that is in the spirit to help the developer to go faster time to market and with a better quality of product.
Okay, great. So, Mark, if I need some help getting started with the STM32WB, where should I go?
Hey, so we have created a lot of content, actually. It's all available online. So here we have an example of a YouTube link. It's a playlist. If you want to search for that URL or just search on YouTube, STM32WB Getting Started series. Today, it has about 14 videos and covering all the aspects of WB. In this video, we really put what we believe is important for a new customer to get the best experience with WB, but also based on all the questions we get on the field and the experience we have interacting with the field. So this is really the best of what you need to know, right? And we continue to grow this series when we have more demo getting released or more feature or question that we believe are important. So please keep visiting that link and come on a regular basis.
Okay, so other than this video series, do you guys have any other assets that could help me?
Yeah, we have a long list of assets, of links and video sources, resources to use to learn more about STM32WB and the STM32 MCU or toolset in general. The best point to start outside of the YouTube I was mentioning before is the st.com. So you can access a lot of learning content, also our massive open online courses or MOOC that brings you hours of content with experts from STMicro. Pretty interesting topics there. You can also visit all these links and explore additional free learning resources that we have for all your benefit.
Excellent. Well, this has been super cool. Thank you so much for joining me today, Mark.
Thank you very much. Good to be here with you today.
And before we go, you didn't forget to click that link, did you? There you can find even more information about this topic from ST Microelectronics. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talks section of EE Journal. You can't miss it, it's right across the top. Or head on over to YouTube, youtube.com/EE Journal.